Good morning, ladies and gentlemen. My name is Ibrahim Abdulrauf. I stand here to present the conference paper on bleaching performance of activated Ashaka Bentonite on cottonseed oil using response surface methodology. This is the presentation outline. Bentonite are alumina-silicate clay that are mainly made up of montmorillonite. There are two types of bentonite mainly, the sodium-based bentonite and the calcium-based bentonite. The main property of bentonite are they have high swelling capacity. It was found that the sodium-based bentonite have higher swelling capacity than the calcium-based bentonite. They have high cation capacity ranging from 70 to 130 milliequivalent per 100 gram. Bentonite also found to have high surface area ranging from 90 meters square per gram to 300 meters square per gram. Acid-activated bentonite are widely used for catalyst support in the chemical industry, as detergent in the paper industry, for purification, decolorization, and stabilization of vegetable oil. This figure shows the location of bentonite deposits in Nigeria. Iram Raw Material and Development Center have reported that there are about 700 million tons of bentonite located in the northeast of Nigeria and about 90 million tons located in Edo State. Bleaching process is a significant step in industry for refining vegetable oil. This process is used for the removal of undesirable substance from oil through adsorption. The bleaching operation effectively reduces the content of chlorophyll, help to reduce residual soap and gum, help to minimize the increase of fatty acid in the vegetable oil, help to reduce oxidation products, and help to remove traces of metals such as copper, iron, and phosphorus. Related works. Wu et al. 2006 did work titled Characterization, Acid Activation, and Bleaching Performance of Bentonite from Zhejiang. And they found out that the bleaching performance of activated bentonite on cottonseed oil was 89%. James et al. 2008 did work titled Bleaching Performance of Nigerian Yola Bentonite, and they found out that the bleaching performance of the activated bentonite on crude palm oil was 87%. Usman et al. 2012 did work titled Characterization, Acid Activation, and Bleaching Performance of Ibishi Clay, Lagos, Nigeria, and they found out that the bleaching performance of activated clay on crude palm oil was 27%. Problem statement. Despite several works in the use of locally sourced clay in bleaching of vegetable oil, Ashaka clay have not been investigated. The aim of this research was to determine the bleaching performance of acid-activated Ashaka clay on cottonseed oil using response surface method, and the objectives are the characterization, beneficiation, and acid activation of the clay, to determine the bleaching performance of the activated Ashaka clay on cottonseed oil using response surface method. Justifications. It will help to reduce the overdependence on the importation of bentonite. It will also help to enhance local content development in the country. Method. This figure shows the flowchart of the bleaching procedure developed for this work. The clay was sourced from Ashaka town in Gombe State. It was then sun-dried for 6 hours and pulverized using a ball mill machine. It was taken for analysis to determine the oxide composition using X-ray fluorescence and determine the mineral composition using X-ray diffraction method. After that, it was determined to be calcium based, after which it was then beneficiated using wet beneficiation method, then oven dried at 100 degrees centigrade for 24 hours. Then it was then pulverized, grounded, and sieved to 75 microns. That it was taken for acid activation using sulphuric acid of molar concentration 5 molar concentration. After which, the bleaching capacity of the activated Ashaka clay on cottonseed oil was determined using response surface methodology. Result and discussion. This figure shows the mineral composition of the raw Ashaka clay. It was determined that it could be observed that the clay had characteristic peak of montmorillonite at Bragg angle of 5.8 degrees and 19.6 degrees. It was also observed that dolomite and quartz are present in Ashaka clay. This table shows the summary of the oxide composition of the clay sample. It was observed that the alumina-to-silica ratio of the clay increased from 0.37 to 0.52 after beneficiation and acid activation. This increase resulted from the removal of quartz from the clay. It was also observed that the loss on ignition decreased from 8.4 to 6.5. This could be due to the removal of carbonous compound impurities found in the clay. This figure shows the single effect of temperature and time on the bleaching process on cottonseed oil. It was observed that as temperature increased from 865 to 85 at contact time of 10 minutes on the bleaching process on cottonseed oil by acid activated Ashaka clay, the bleaching capacity increased from 36.8 to 38.2 degrees. It was also observed that as the contact time increased from 10 minutes to 20 minutes at constant temperature, the bleaching capacity of the activated Ashaka Bentonite increased from 36.5 to 39.2. This figure shows the combined effect of temperature and contact time on the bleaching process by the activated Ashaka clay on the cottonseed oil. It was observed that the optimal bleaching capacity of the activated Ashaka clay was 40.2%, which was lower than Yola bentonite, which was 87%, as reported by James et al. 2008. This could be due to the low concentration of montmorillonite present in Ashaka clay. Conclusion. Based on the X-ray diffraction analysis, Ashaka clay had montmorillonite, and the chemical composition of the raw Ashaka clay had alumina-to-silica ratio of 0.37, which increased to 0.52 after beneficiation and acid activation. The optimal bleaching performance of the acid-activated Ashaka clay on cottonseed oil was 40.2% at temperature of 75 degrees centigrade and contact time of 22 minutes. These are some of the references. Thank you for listening.